Hi, welcome to another episode of Algebra in Words, the video series on YouTube. In this video, we're going to begin our discussion on quadratic equations and their resulting graphs, which are parabolas. So this video is going to serve as an overview where I'm just going to give an introduction to quadratic equations, quadratic functions, everything that we're going to learn about and that we can take from the quadratic function, how it can be interpreted, how it can be graphed, and everything in between. So anyway, let's get started. Quadratic equations and quadratic functions are all centered around this form is in the function form because it starts with f of x. But if it started with y in place of f of x, we would call it a quadratic equation. They're basically interchangeable. It's just a matter of the manner in which they're written. But they're basically the same thing. Notice that these all come in the form of ax squared plus bx plus c. And when it's set equal to 0, that's what we set it equal to when we want to solve it. And when we solve it, we're solving it to find the x-intercepts. I'll go into that a little bit more in a minute. But just to go over the basic fundamental details of this, this is the standard form of a quadratic that you always want to put it into unless otherwise noted. There's different situations for different equations and forms, but for now, we always want to put our quadratic equations in standard form. Ax squared plus bx plus c equals 0. Now, as we'll see in future segments, every equation will not always have every part of the equation, whether it's the bx or c. And I briefly went over that in previous videos. But all in all, to be a quadratic equation, it must have the ax squared portion, because the x squared represents a 2-degree equation, and a quadratic equation is a 2-degree equation. Can't be higher and can't be lower. They would make different equations and would graph into a different graph. So what I'm going to go over with you in this and next videos, related videos, is I'm going to teach you how to solve by the following methods. And remember that solving a quadratic equation or function means finding the x-intercepts. It literally means finding the place where the graph crosses the x-intercept. And again, I'll go into that in more detail in a minute, but just as an overview, there could be 3 possibilities. You could have 2 solutions, a maximum of 2 solutions. You could have 1 solution, and you could also have no solutions. And I'll explain graphically how and when that could be. You could also have situations where no solutions really translates into imaginary numbers or complex numbers, which again, I'll go over a little bit later. But I did go over imaginary numbers and complex numbers in a previous video. So what I'm going to teach you, how to solve by the following methods, or some of them I went over in previous videos already. But the point is that you can solve quadratic equations and functions by the following methods. It can either be factor and solve, basically by the trial and error method or the reverse FOIL method. You could do it by the AC grouping method, which is really just another way of factoring and solving. And again, I went over that in a previous video. You could also do it by the complete the square method. There's a time and place for that. And also, as we're going to see, the complete the square method is going to be used for solving and graphing circles, which I go over in a later video. Then there's the quadratic formula, which is very important. I'm going to go over that in another video shortly after this. And you could also do graph and check, meaning you're given the graph and you can read it and plug in what you think the x-intercepts are into the function and solve that way. Or you could even start with the equation only and put your own numbers in to graph it and then solve that way. Also, it's worth saying that starting with the quadratic equation is there are many different details sort of encoded into that we're going to use to find the following information, which we can ultimately use to graph. Sometimes they're just questions that are asked about it that we have to analyze for, and sometimes we use it ultimately to graph. But it all kind of fits together. So also what I'm going to teach you how to do is, I'm going to teach you how to find the X-intercepts. We basically just went over that. That would be using these methods. The X-intercepts are what we would call the solutions to the quadratic functions and graphs. I'm going to teach you how to find the Y-intercept, which, spoiler alert, is exactly the same as finding the Y-intercept for linear equations as well as any equations. But we'll just focus on that a little more in a minute. We're also going to look at what does the sign of A mean. That's why it's important that we always put quadratic equations into standard form, for now at least, because we need this A, and the A is going to tell us whether the parabola, which is a U-shaped graph, points upward or downward, and I'm going to go over that shortly. Then we can also use the equation to find the vertex of the parabola. That's basically the tip. In the case of parabolas, the vertex is a tip, but the vertex can be used for different type of equations and graphs as well. We'll also see the vertex in circles. A vertex is usually given by the form of H and K, and I'll go over that more shortly, but H represents the X of the vertex, and K represents the associated Y value of the vertex. But basically these are just specific values of X and Y. The vertex also can be used to tell us the maximum or the minimum of the parabola. And then we can also find from that what's known as the Axis of Symmetry of the parabola. And finally, using all of this information, I'm going to show you ultimately how to graph a quadratic equation into a parabola. And then also sometimes we do the reverse. We are given the graph and we might have to sort of reverse engineer it and answer certain questions like this, or even try to develop the equation from the graph. So what I'm going to do is erase half of this, and I'm going to put 3 graphs on the board so that we can start to get a little introduction into the conceptualization of the graphs. Okay, what you see is I put 4 basic graphs on the board, a few sketches. Nothing specific, but this will be a good introduction into just getting comfortable with the graphs and what to look like and what to expect. So what we're going to do is we're going to look at each of the 4 graphs, and we're just generally going to locate a few things. We're going to identify whether it opens upward or downward, and therefore predict the sign of A. We're also going to look at the number of solutions that there are associated with each graph. And we're going to locate the vertex, we're going to locate the axis of symmetry, and we're going to locate the y-intercept as well. So let's start with this one. Now the first thing that I want to focus on is, and let's look at all 4 in this case, is just the x-intercepts. And remember, the x-intercepts are the solutions. When you solve a quadratic equation, it's to find the x-intercepts. That's what solving means. So that's why I think it's important that we first look at the x-intercepts, because that's what solving is. In this graph, there are 2 x-intercepts. One here, and one here. It's just where the parabola crosses the x-axis. In this graph, the parabola touches the x-axis. In that case, we would say that that related quadratic equation has 1 solution. Let's look at this one. In this case, it doesn't cross the x-axis at all. It does cross the y-axis, but that's different. It does not cross the x-axis. So this is an example where if we were to solve, we might get no solution. Or if we solve by the quadratic formula, we might get imaginary numbers or mixed with complex numbers. But the point is that you can have no X-Intercepts, or no solution, but really you'll find that they come as complex numbers, but still have a graph. So what you want to remember for this example is no solution does not mean no graph. There can be a graph, but there can be no solution because it does not cross the x-axis. And finally, I have this graph. This one again also touches the x-axis only once. That would have one solution. Alright, now the difference between this graph and the other three is the direction that the parabola opens. Now if we look at this, and this, we say that the parabola opens upward because the u is opening upward. How do we relate that to the equation? Well, we always relate that to A. The sign of A tells you whether the parabola is up or down. And although I don't have the following written, I'm going to say it. So A represents a coefficient or a number. There's no sign written in this form, but A could be either positive or negative. If it's positive, you won't see a plus sign there because we don't write that. But if it's negative, then it would be, you would have an actual number written in place of this, and it would be negative. A positive A means the parabola opens upward, and a negative A means the parabola opens downward. So all three of these would have a positive A, but in this case, this would signify A is a negative number, and it's shown by opening downward. Now let's look at all four for the y-intercept. And the y-intercept is just the point where the graph crosses the y-axis, just like for linear equations, which you've done a million times and I've done in previous videos. If we start with this one, where is the y-axis? It's right here. That's all. And also, how would you find that in the equation? Right there. C is the y-intercept. There's no work that you need to do, assuming that you already put the equation in standard form, which is why we need to do that. But there's no calculations involved. You just look at C, and C is the y-intercept. Graphically, that would be here. What about for this one? The y-intercept is right here. Okay, and how about this one? The y-intercept is right here. And for this one, the y-intercept happens to be right here. And I made this graph because at this graph, the x-intercept and the y-intercept happen to be the same. They're both at the origin, 0, 0. Alright, so now we talked about y-intercept. But now let's talk about the vertex, and let's locate the vertex in each graph. Now also, as I have like a sub-bullet point here, sometimes you'll be asked about the minimum or the maximum of a parabola. That depends on whether it opens upward or downward. You can't have a max and a min, you can only have one or the other depending on how it opens. If it opens upward, you would have a minimum. And if it opens downward, then you would have a maximum. So here's how you can find, so first of all, finding the maximum or minimum, you basically find from the vertex. If you find the vertex by being given the graph, then you just look at it and focus on the y value. Or if you're not given the graph originally, in a soon to come, I'll show you the formula from which, using the standard form equation, you can calculate and determine the vertex, and from there, the max or min. So anyway, if we are locating the vertex of this graph, it would be here. And would that be the maximum or the minimum? It would be the minimum. Okay, and what specifically is the minimum? It's the y value of the vertex. So if we trace that over to here, whatever that y value would be, that's what the minimum would be. These are just basic sketches for now. What about here? In this case, the minimum, the vertex would be here, happens to coincidentally be the same as the x-intercept in this case. And that's the vertex, and that would also be, the y value of that would be the minimum. What about here? The vertex would be right there. And since it opens upward, that would be the minimum, and we would get that from the y value of that point. And finally, what about this one? The vertex also happens to be the same as the x-intercept and the y-intercept. That's just coincidence in this case. And in this case, this would represent the maximum because that is the highest y value because it opens downward. Okay, so that pretty much summarizes everything that I wanted to say about that. One final thing is, what about the axis of symmetry? What is the axis of symmetry? An axis, first of all, an axis is like a line, and of symmetry tells where if you drew the axis of symmetry, it would mean that the left side sort of mirrors the right side. That's basically like splitting the parabola right down the middle, if we're being honest. So why don't we, I'm going to change marker color, and let's first draw the axis of symmetry, and then I'll explain what it is. So starting with this one, that would be right here. Right down the middle. Now, how would we be able to write that as an answer? Well, that's easy. Just like when we looked at the max or min is the y value of the vertex, or we could say the k, but that's the y value of the vertex. To find the axis of symmetry is the x value, or the h, of the vertex. So all you would do in that case is set x equal to the number that would be represented by that point. And again, these are just generic, but if we're making up a number, suppose this is x equals 2, we would call the axis of symmetry x equals 2. What about this one? Draw the line right down the middle through the vertex. And whatever the x value is of the vertex, that would be the axis of symmetry, and write x equals that number. For this one, it would be right here. Again, the x value of the vertex. And likewise for this one, I really should just trace the y-axis because that's what it is. And so in that case, the y-axis would represent the axis of symmetry. And since we know that the y-axis is represented by x equals 0, then we knew that we know we could call the axis of symmetry x equals 0 for that. So I'm going to end this video, but in the next video, we're going to start doing calculations to find the vertex and ultimately graph. So thanks for watching, and see you next video.